Right. So remember to contact me if there's any assignments you did not get to do before the pandemic hit. That'd be around week 6. And that way I can make some kind of adjustments for you. Additionally, there is, I should say, a assignment was actually offered as extra credit for a research project. And you also have chances of doing a quick little snippet. Take a article about air conditioning and write up something on it. Really simple, little quick statement of how it affected you or how you feel about it. And that has been going on since the beginning of the semester. So it's nothing complicated. It just gives you 5 extra points each week on up to 5 weeks. And we're down to our last 4 weeks coming up pretty doggone soon. And the final is coming up too. So I'll be actually giving you some prequels of what the final is going to be like on an upcoming week. So you really want to be here on time and in class. And which brings up the final. The final, you definitely have to be on time to make that happen. If you're late, I do have an option of not allowing you into it. There is more security functions in Zoom now, and they allow you to lock the room. So it's just like somebody locking the door at when the class starts. So keep that in mind. I don't know if I'm going to really enforce that very hard, but I do have to proctor it, and I want to be able to help all of you as much as possible. And that brings up another point too. The final is going to be all the finals week. So you're going to have 2 days of final. You're going to have some of the final on one day and some of the final on the next day. Believe me, there's quite a bit of work to be done. And like I said, I'm going to be prepping you as we go along to make sure you do well. You just have to do the work. All right. So that and this, like I was saying earlier, this is the week that the instructors, and this is for all your classes, if there are people that are not participating in class, the instructor has up to this Sunday to actually drop. And if we kind of look at attendance, we look at if you're doing the work, and we're also looking at your grade. We hate to give anybody an F. That's can actually hurt your financial support, and it doesn't look good on a transcript when you try to go into another college. So we're balancing this all out. So that's what I say. I may be reaching out to you if you have a substandard grade. This would be all individually, but I do want all of you to continue, and I want you to do all well. But there again, you earn your grade. I don't give you grades, you earn the grade. So keep that in mind. You have up to the 23rd again this month to do late work. So please get it in by then. I can't really let it go beyond that. I need some time to update the grade book and make sure everything happens. So again, look at your grades, look at stuff that you were not able to complete because of the pandemic. Reach out to me. A few of you already have, and I've made some corrections already. And I've asked questions on a few of you too, because some of it was just, you give me a week, but you don't really tell me what you didn't get a chance to do. So make sure that happens. And please, I want you to do well. All right. So anyways, let's get into today's subject. Today's subject is going to be, like I said, we're going to be talking about, let me go ahead and share the screen with you right now. But we're going to be talking about controls. So we've been, at the beginning of the semester, we started off with more talking about the refrigerants and how they react to temperature, and how the different pressures and the different states of the gases as it goes around, and how it actually reacts to the temperature as it goes through. And well, now what we want to talk about, and we started, in the last few weeks, we went into some of the basics on electrical and how this is going to help you with your diagnostics as you go across too. So now I want to start talking a little bit about the actual controls, the compressor, clutch control. How does it come on? It's not like it used to be. There used to be a time when you pushed a button and the compressor automatically came on. Now it is more of a request from you to the actual compressor control, whether it be a module or an BCM or a PCM. This was, this changed as we went along. So let's go ahead and share this. All right. So so this is what we're going to be talking about as we go along here. And so, there are two primary methods of maintaining evaporative temperature to prevent freezing. And if we allow that compressor to stay on without any kind of control, it will actually go into a block of ice. And this is not what we want. We want to be able to blow air across it. So we do a couple different ways. We either use a cycling system where we actually turn the compressor on and off. It gets down to, on the low side, somewhere around 28, maybe 26 PSI, which is about, if you think about it, we get down to 30, we start forming ice. So we kind of bring it down to that, and then we turn the compressor off. So we cycle it off. Or we go to what, some of the compressors are what they call a variable displacement. We can change the pitch of the actual piston inside the compressor. And we can go to a neutral position or change the actual different displacement of that and make it happen. All right. All right, so here I'm kind of going into a little bit again of, the different types of ways of doing it. So here, we have a cycling system where we will use a pressure switch, and we'll use a actual temperature sensor. And this temperature sensor is directly pushed into the evaporator. And you'll notice that little bulb here. This is a thermistor, and it's very, very similar to what we use in our air temperature, in our engine performance, and also our coolant temperatures. We use a lot of the same type of sensors to do that. This helps manage. So this information is all put into the PCM to actually control and make sure that, this is, make sure it doesn't form ice or get, too cool. So this is just like some of the controls that we actually use. Again, we really rely on the actual relationship between pressure and temperature. So keep that in mind too. All right. So here it actually shows some typical, the way it's typically blocked. And please remember, this is a block. This is not an actual wiring diagram. This wiring diagram would be different, but this is just kind of a block representation of how it's all put together. So it has, of course, power going into the control module, and then we'll have like a high pressure switch, which will turn it off, the compressor off when it gets too high of temperature, too high of pressure. And this, again, it's in relationship with pressure and temperature. So if I looked at this and that actual high pressure switch had actually cut off, I'm looking for possible one overcharging, which could happen, but also I'm looking for fan controls, airflow not coming across to take the heat off. Remember, that you're looking at 430 psi. That's gonna be pretty close to 400 to 450 degrees of temperature, and that freon getting the refrigerant getting very, very hot. So that compressor is going to be overworked if we can let that continue to go, and we could damage the compressor. So to alleviate that, we'll actually turn the compressor off also. If it gets too high, and some of the bleed offs on, it's a pressure control too, it will actually vent the refrigerant to atmosphere to protect that system also. We can start blowing off hoses, we can start damaging compressors. So this is all taken in consideration, trying to protect the system. And then we have the low pressure one. So it shows you the cycling, between 22 and 43, and that would really be manufacturer specific. I've seen some of them cycle off at 26. So this is, this is one of the things that you really need to know. Is it right? Is it wrong? And the only way to find that out is through the manufacturer specs. So then we actually have, in front of that, all the way over to the right, we have a request. And it's really what you need to remember. It's a request. It's not a, a complete, I push that button, the compressor comes on. It goes into a request mode, goes through the different parts. And it's, again, we're talking about computers, and it will be an on-off signal. And if it's, if I get a request and it goes through the cycling switch, okay, it says everything's cool. And then I go through the high pressure switch, so everything's cool. Then I go into the control module. So it all gets fed in that way. And then on the upper side, we have the actual command out. If everything looks good, that control module says everything's fine, then we'll get a command to turn on that compressor. So this is something that we need to take in consideration when we're looking at when we start doing our diagnostic part of it. So the high pressure cutoff switch, I kind of went over that, is wired in series with the clutch cycling switch and the system protection device located in the high pressure side of the active system. So depending on what kind of system you have, you're going to have 2 switches. You may only have a cycling switch if you have some of the older systems like that. But still, we need to know, and this is where that wiring diagram is going to help you a lot to figure out, okay, what devices do I have that actually give information into the computer? And when the AC signal is received by the PCM, if all system parameters are correct, the PCM provides a ground for the actually AC clutch relay and the clutch engages. Now, this is another thing that we need to take in consideration. We're only looking on the AC side right now. That control module is also taking information in from other modules out. One example is the actual the PCM. The PCM actually has information that this control module might need. One, is the vehicle running? 2, what speed is it at? What kind of demand is going on? What temperature is the vehicle at this time? And depending on the manufacturer, they may not allow that compressor to not want the AC on until the vehicle is up to a certain operating temperature. And also, if we go into a demand mode, so we want to accelerate really hard and we need a little more of the engine performance, it will actually tell the AC control to shut down, turn that compressor off. We need to get as much of the performance as we can. So this is where there's getting talk from the compressor, from the control for the compressor and the AC. It's actually talking to another module. This is nothing new. We actually had an early computers, and this is back before we went into a CAN system with the different modules. We actually had on the early systems where the fuel control was as part of the system, there would be a request into a ECM or PCM, and it would have a control function. If it's seen the TPS or the throttle position sensor at wide open throttle, it would not allow the compressor to come on. So this is not new. It's just the way that they actually do it now, and they share information across different systems. So here is more of a better picture of a, more, closer to a wiring diagram. I wouldn't say this is 100% what you would, but this more so showing how internally the actual the module is wired up. So it's looking at the, this is again, it's showing that relationship between our actual control module here to the actual PCM, and how it has some shared information, some actual command going on like that too. The only way to really you can use a voltmeter to actually go in and see if things are going, but really you need to find out what the computer is seeing, and this is where a scan tool comes in play. And before in air conditioning, we never used the scan tool. It was just a matter of controls and switches, and we would go through and take our voltmeter and go through and check the different circuits, and we knew what needed to be where. Now you really do need to see from the computer standpoint what is being, what kind of information being shared and what kind of information is going on. So you really want to look for these the pressure sensors and also the command. And this is true, it comes to a good point too. If you are not getting a request coming in to the actual module, that might be a control head problem. So this is something that the only way you can really get it is through an actual scan tool. Here is just an actual picture of a high pressure switch, and depending on how the type of system you have, it may be just a control for the cooling fans to come on, the condenser fan to come on if you have a separate one for that. Maybe you have stacked AC fans or cooling fans like that, and it also might share your responsibility to send information back to the actual actually to the module controlling the compressor and the air conditioning system like that too. So in it, again, it comes down to if it gets too high of pressure, the switches will be different for the cycling one versus the high pressure one. It will send information back to the module to make sure that it is controlling that compressor more finely. This is actually a different type of switch. It looks very familiar, and to me at least, and this helps with the controlling the actual information, so we can actually turn on the cooling fans, energize the fans and pulse the fans. And it used to be we just sent ground and power to the fan. Let me let somebody in here. All right, and it let voltage onto the fan, and we would have power and ground, and it would go on full tilt. Now we're actually pulsing or modulating the fan control. So we'll give the fan a certain duty cycle to where it'll come on to a certain speed. And then if we really need a lot of fan, we'll turn it on even faster. So this is where we're getting information, and we're actually changing that, not just so much voltage, we're actually allowing so much of the fan to come on. This is a picture of actually that little sensor I showed you a little bit earlier. This one that goes right into the evaporator, and it senses the actual surface temperature of the evaporator, and it gives feedback to the control module to tell it, hey, we're cold, we're not cold. We can actually have a little more of our refrigerant coming through here to absorb some of it. We may have too much going on, so we need to start shutting things down. And it's very similar to the different temp sensors we use in the engine performance side. Here's another sensor that actually is a little bit different design. That you're going to see CAN and CAN bus again, this has to do with sharing information between the different modules. And this is one of the type of sensors that are in there. This is again showing the sensing devices and how they're actually wired in, and how they actually are placed. Here we have the IAC relay, of course, kind of going into the out, where you want to get the compressor clutch. And notice it uses a Zener diode in this one. The Zener diode's a little bit different than a clamping diode, not a whole lot. We use a lot of Zener diodes for voltage regulation. So this is going to help keep from damage going into feeding back in. High pressure switch, low pressure switch like we've seen before. Then we have the evaporator temperature sensor, depending on what design we have. And then we have feedback going through. And you'll notice it actually has, here's my 2 AC switch here going through. Another type of evaporator temperature sensor, just the way they actually design it and they put it into play. So this is going to be one of the designs that, and you may see a BCM for body control module. And it just depends on how the manufacturer wants to call their modules and how they lay them out into the system. Pressure switch, this one monitors the high pressure, and it will, if it gets too low, it's going to help, with it. If it gets too high, it's going to be part of the fan control on it also. Not just sending information back to the computer or the module to tell it, hey, we're getting too hot, we're okay. It might even, be part of the fan control. Compressors, variable displacement, like I said earlier, we can leave the compressor on all the time. We just change the pitch of the actual piston profile, and we can either go for a deep stroke, we can go for neutral it out, so where there's really no refrigerant being transferred around. And you're going to notice that, and I'll have a picture in here, but the device that you see up here is the control. That's actually what's allowing that actual wobble plate to displace different profiles. Here's that valve, and actually, it uses it's like an engine, you might say, and it actually, it's almost like an engine setup, but it actually, by changing the actual feed, we can actually cause it to change that profile. We'll move that profile around. The control valve senses pressure on the suction or low pressure side of the actual system. As the evaporator pressure temperature increases, low side pressure increases. The control valve will direct system low pressure into the compressor crankshaft. The compressor internal cylinder pressure will now be greater than the compressor crankshaft pressure. This causes the compressor to increase piston stroke with increased compressor output. This is a serviceable piece. Not many people know about it, and this is what gets misdiagnosed sometimes too. As the evaporator cools down, system low pressure drops, and the bellows and the control valve now bleeds high side pressure into the crankshaft, into the compressor crankshaft. Crankshaft pressure is now greater than the compressor cylinder pressure, which reduces the piston stroke and the compressor output. So it changes the profile. So instead of being really aggressive, it kind of almost flattens out, and it'll change different depending on the pressure as it goes across. So you may have a really aggressive stroke when there's an imbalance, or if you get to where it kind of pressures equalize, you're going to get almost to a flat stroke. And this is just the valve itself showing you how it actually is put together and how it actually does, is what it does. And this is that compressor feed. That's very important. These, in the field, I found is these, whenever I start seeing issues with these, you know, of course, they're kind of a mechanical device internally. There's a bunch of springs and stuff like that. If you're crazy like me, you take them apart. But what I have found is contaminants. And this is where, you know, your customers might not understand this, but there's something education that we need to do with our customers also is this does need to be serviced. I would say a minimum once a year, just to check the refrigerant, the refrigerant levels, and also it's a good time to kind of clean it out a little bit. That refrigerant oil is just like engine oil. It needs to be serviced. And does it need to be serviced every 3 months? No. It does need to be looked at, and it can have properties that break down inside of it. The other thing is too, the oil, like like in any oil, it collects debris, and if there's any kind of debris that might be in the system, possible hoses starting to break down a little bit. You know, when you get in some of the older vehicles, the walls of the hoses will tend to disintegrate, and then this debris actually get collected through the whole system. Plus, you know, again, the compressor is a mechanical device, and it needs to be, you know, serviced, and this is where the oil comes in play. So it's just some of the things that I look at when I'm talking to my customer, you know, when was the last time you had any service work done in your AC system? And a good time to do it is right before the hot season comes up. And our hot seasons have been longer and longer here lately. It used to be, it was, you know, we had winter, and then there was a little bit of time, and then you went into a warmer climate, you know, more so towards, you may start getting a little bit warm in March, and then you kind of lead yourself into, you know, June, July. That gets to be a little hotter. That was kind of our hot season, but you know, it's getting to be a little bit more and more towards, you know, more time warm than it is cold. You know, you talk to scientists, and they talk about global warming. You know, it depends on how you feel about it. I do feel that we do have a problem, and I'm curious about how the numbers are going to be with the CO2, since, you know, a lot of people have not been driving. We'll see what it comes out like, you know, because the pollution level, believe it or not, has actually gotten better because of less people on the road. Anyways, we've got people coming back in. Okay. All right, so this is a control valve, like I said earlier. This is actually the variable displacement compressor. Internally, it's different. It's not like the old style compressors. And this is just kind of a cutaway of one looks like. It doesn't have a clutch to it. It just has a drive belt, and it will change its pitch instead of changing its, it doesn't cycle. It just stays on all the time. We just change the pitch of the piston. And that's pretty much on that end of it. We're the controls and like that. I want to kind of stop for a second here and ask if there's any questions on that. This is just really going into the control side for the compressor. What I want to kind of do is, because it's some of your actual final exam is going to be talking about airflow, and not just in the outside, but also in the internals of the, you know, the passenger compartment. And I kind of wanted to go over a little bit of that before we close up today's class. So go ahead if there's anybody that has any questions. I mean, it's kind of hit you hard with it, and we're going to be going a little more over the controls as we go through the semester. So any questions so far? Okay, I take that is no questions. So what I want to do is continue on, and we're going into the section 7 of actual this presentation that Max has put together. This is going back over the blower motors and talking about the importance of circulating air through the capacitor compartment to make things work. Because as we know, heat is attracted to cold. I've been talking about this from the very beginning of the semester, and with knowing that, we need to be able to circulate the air across that actual evaporator. And we do know the importance of circulating air over the condenser to dissipate heat. So basically what we're doing is we're taking the unwanted warm air that we have in the passenger compartment, and we're taking it and we're dumping it outside is what we're doing in a nutshell. So the blower motor is located in the plenum, and it's in strategically placed so we can actually draw in either in the recycling mode where we're blocking off the exterior air or the outside air, or we're bringing in air outside air in to actually get fresh air inside of it. It pulls it through the passive evaporator, through the heater core, and it goes through all the different ducting. And it's just through the controls that we push it out to the registers, out to the passenger's face area, or we're actually pushing it up to the defrost mode, or we're pushing it down the floor for the heat mode, like that. So the blower motor uses the various means of regulating the blower speed, and this really comes down to what kind of system you have. We had the old control system where it was a kind of a flip switch that actually changed the different speeds through a dropping resistor. Blower motors are small, have a small hose, and it directs directs air from the plenum into the motor to keep it cool. These need to be put back. I've seen too many times that where this hose here, which actually is really, it doesn't really show you very well, but it helps keep this electric motor cool. It actually has a flow going through, and if you take, this is what happens when you get, I'm not trying to put anybody on, but when you get a customer that does their own work, they forget to put the hose back on, and then they want to know why the blower motor fails all the time. Well, it's not getting any air flow coming through. And when we do get air flowing through here, and because of what is going on inside, we can actually get cooler air than the interior air, the actually cabin. So it's very important that you put that hose back on. Now, this is the old style. We had a panel with a position switch, and you see these different positions, and it shows the little blower motor here, and it says 1, 2, and 3, and they probably have a high on the end right here. So this would give you the lower speeds, and then it would be a direct either off the blower relay straight on to a exact 12 volt and enough amperage to actually spin that blower the fastest speed. We do use blower motor relays, and like I said before, we may switch this over to high speed using the blower motor relay. And again, I'm gonna harp on this a little bit, but make sure you put the correct relay in. There are relays that have diodes in them, and there are relays that have resistors in them, and there's relays that do not have either one in it. They're there for some specific function, and make sure if you're doing some swapping, it's very common for technicians to swap relays, that you do it right. If you do 1 for 1, in other words, the right one goes in there, and you could have ill effects if you don't. If you're testing that relay, I shared with you on Tuesday about testing relays, and one of the things I recommended was using a test light to energize. That's it. All I'm doing is to use it to energize. And if you don't remember that, we had a video of that I actually posted for you too. But make sure that you test it correctly. Don't just directly connect a set of jumper leads from the battery to the actual relay. you could damage that diode or that resistor that's in place. This is some of the old, we don't use this as much, but these are actually those different resistor blocks that we used. And these resistor controls were for the blower motor to drop the actual blower motor speeds. And they, and a lot of times what you can do is you can pull these out, and you turn the fans off, you shut off the vehicle, you take 2 screws out and you pull these out, and you will actually see if you have a speed that's not working, actually the coil will have been broke. Do not run these out of the airflow. They will get destroyed. I mean, young, dumb, and trying to figure out how things work. Me, I always take things apart. I turned one time. This axle, and it's kind of interesting to see this happen, but this actual coil, this coil wiring right here, that resistor right there actually glows. It gets very, very hot, very, very quick, and it melts down. So I actually destroyed one of the resistors, just wanted to see how it worked like that. So take it from me, don't do it. And here it actually shows, a little bit of it. So many resistors are equipped with a thermal limiter. The thermal limiter will open if there is an airflow restriction. And this kind of protects that little guys like that. And then we go into what they call the credit card size ones. And this is going into more of the resistor, variable resistor designs. And Zeus, you good? Okay, I heard the fan. I thought maybe there was a question coming up. So these are more of the modular designs, and sometimes they call them credit cards and stuff like that. And this is what actually for the blower motor, instead of doing the old coil type resistors, they're actually using resistor boards to do them. Then we go into the power modules. This is where they're going to be cycling or modulating. This is going to be communication from the actual module, and this will be feedback coming back and forth to actually go. And you notice the big resistor. There needs to be a cooling board or a cooling fan. So okay, so this is a brushless, blower motor. Many vehicle manufacturers have started using brushless motor blower motors that use pulse width modulating to operate the blower motor. The brushless blower motors use magnets and transistors that are pulsed in sequence. When the like poles of the magnet are lined up, they repel each other, causing the blower motor to turn. It's kind of back to your magnetism principles when we were in electrical class. Both of the power module control and the brushless motor designs are controlled by a pulse width. In other words, we're not turning just on and off, we're actually modulating the current going into that motor to make it work and make it spin. And this is a typical screen. And this is where if you wanted to, and we can do it, is take a lab scope and see what kind of a pulse width, and depending on how much blower motor is needed, or to the speed of we pulse the actual voltage on and off. So you'll notice this is up to, I think it's up to, let's see, 6 volts. Maybe we got a little bit more up here. And this is actually, and we look at how much time we're pulsing on, almost like an injector, like a fuel injector. And this is actually checking the blower motor for duty cycle. So you can set your DVOM up to voltage, and usually you're using a AC voltage, and it actually you'll watch the how much current is actually being pulsed. It's like almost like the screen we've seen before, but now we're just putting it to a duty cycle type. And then, this one here is actually pulse width modulated. Again, we're actually looking at it in hertz, how much time from 0 to 100% of, the actual duty cycle. So we're actually very, very high on this one here. So blowers and cabin filters, of course, diagnostic tips. I just kind of want to, kind of close it off with this. Allow a blow motor to run from 5 minutes before performing a current draw test. So it takes a little while for it to actually wind up. So don't just automatically put your clamp probe on it and expect to get a draw right off the get-go. Poor grounds can lead to motor failures and can be a source of noise on the radio too. Old radio way of looking at things. Loose or dirty connections can lead to motor and power module failures. Check the blower motor wheel. Sometimes we call them the squirrel cage. And if they have cracks in them, you may, and I shouldn't say may, you will find on occasion where customers have things up on their dash and things fall down inside, and the little squirrel cage or the blower wheel is actually plastic, and it will get in there and you'll have the actual wheel fracture and crack. And they'll cause a lot of noise. And if a piece dislodges, it can actually bind up into the actual ducting, and you may have that where it freezes up that blower wheel too. I found pencils and pens and Disneyland tickets and all kinds of stuff down inside of them like that. If the thermal limiter on a resistor fails, check blower current draw. If it draws too much, it will cause it to overheat and cause that thermal switch to pop like that. And inspect the air filter and evaporator for restriction. And this is where it comes in important. With the filters in place now, if we have a restriction, it's almost like your engine on your car. If you have a restriction, it overworks that engine trying to get it to spin that engine. Same thing with that blower motor. If it has a restriction, it's going to take more current to get that blower motor to spin, and then you can actually have it pop an actual circuit. And it can cause that thermal limiter to pop, and it can cause a higher draw, and it can go to the point where it actually pops fuses and possibly start melting some wires too. Okay, you usually see it right on the connector where you get that black and that melting of the plastic and like that. So, cabin filters, purposes, of course, is to actually remove dust on pollen and odor causing matter. And, for years, we've been just taking road dirt, running it through the ducting system. And so we would actually, honestly, after a few years, we would actually have to take the ducting out of the car and clean it all out because there would be so much contaminants depending on where people were. And if you get in a real dusty desert area, you may have quite a bit of debris inside, and enough gets packed up against the evaporator or the heater core, then you don't have that transfer of heat. It will coat it, and we would have to take them out, and then take like a garden hose through the whole ducting just to keep it, get it cleaned out so we could put it back together. So the adding in the actual filters was a great part. We do not get the contaminants through it. It keeps it cleaner, and then we don't have to breathe in the other part too. So that was the health part of it too. This is just, again, showing the filter, and it can cause restriction. This is another a component that we need to check during our normal checks. And this doesn't just have to be the AC check. It can be your normal inspections on the vehicle when you're bringing them in for, for oil changes or whatever. But this is one of the things I do check, especially when I have a customer complaining about, it doesn't seem like it's getting very cold. and I'll go out to the car and I'll just put my hand up against the actual vent, and there's no airflow. Okay, so then I have to go through, well, one of the things I do is I go find where the filter is, and I pop it out and I inspect it to make sure it's not plugged up, restricting things. And there's been many a times that I've done it. And actually, a friend of mine, her really good friend, was complaining about, it's not getting cold. And I went up and visited, and actually says, it's slowly but surely not getting cold. I don't know. Maybe it needs some, maybe it needs some Freon. And I said, well, let me look at it. And this was a little Hyundai, and I popped open this one was actually right at the glove box. I popped open the glove box, and there was where it kind of slides on in, and I pulled it out, and I am not kidding you. I had so much. She must be parked right by a fruit tree or something like that, because there was all these beads that I pulled it out, and it was just packed. I took a baggie and got all the rest of the debris out, borrowed a vacuum, cleaned that all out, put a new filter in, and it, you could just feel the change on it. So you'll find this kind of stuff. And for you that are close to critter land, as I call it, you might find little critters living inside too. People park their cars in spots. I mean, when I was right over by Torrance, there was a hill up there with a really expensive houses, and people have several cars, and they wouldn't drive certain cars for a long period of time, and they would bring them down either for wiring problems because the critters ate the wiring looms, which was a challenge too, or they would have vermin actually living in certain parts of the car. And one of the places they really liked to put their nests were in the ducting of the air conditioning areas and stuff like that. So just some things that I've actually experienced along the way. So all right, so right now I want to go ahead and stop for today. I'm going to head and stop this part of it and kind of get any questions that you might have, and then you have quite a bit of work to do, so plan on, we have a discussion group, we have quick quizzes, and you have the module quiz too for this week. Next week we'll start up again with some more stuff. So is there any questions for me to start off with? And either you all fell asleep, which I don't blame you, you're probably on your jammies right now too. But very good. So what we'll do is we're going to go ahead and close out the class for today, and we'll meet back up on Tuesday of next week, and we'll get deeper into it. And like I said, for the next 3 weeks, finals is 4 weeks away after this week. But for the next 3 weeks, I'm going to be prepping you for the final exam. So plan on being on time, plan on taking notes, plan on start reviewing, which I'll be starting to do too in the next few weeks, is reviewing what we've done all semester long. And I'll start giving you more tips, and we'll be talking about the pressures as we go along too. So I bid you a good day and take care of yourself, and class is dismissed. I'll see you on Tuesday. Take care of yourselves, folks. Bye.